Today we're gonna talking about dot product. For example, we have vector A and vector B. The angle between those two vectors are theta. Vector A dot with vector B equals to the magnitude of vector A times the magnitude of vector B times cosine theta. It also equals AX BX plus AY BY. So what does this mean? What does this physically gives us? So if we can consider in the following way. First, we can make a projection of vector A on vector B. And this part would just be the magnitude of vector A times cosine theta. So A dot B is AB cosine theta. And it's just the projection of vector A times vector B. So how does this relate to work? Work is defined by force dot with the displacement. So it equals to the magnitude of the force times the magnitude of the displacement times cosine theta. Theta is the angle between force and displacement. Here we are looking at one example. So there is a hill 30 degrees to the ground, and there is a person climbing up the hill. The person is holding a weapon. The person gives the weapon a force. Upwards holding force. The force is F. Pointing up, and the displacement is along the direction of the hill. So how much work this person does when this person carrying this weapon from here to here? Work in this case would be equal to force times displacement equal to the magnitude of the force times the magnitude of the displacement times cosine theta. So this is just the magnitude times the magnitude. It's not a dot product here. If we draw this here, would be displacement vector here, force here, theta here equals 60 degrees. And if the displacement is 10 meters, this is 5 Newton. This would be 5 times 10 times cosine 60, which would be 1/2 equals. So you can see this part we can consider as we do a projection of the displacement on the force direction. This would be d cosine theta. So how much work this person does to the weapon is just the force times the displacement on the force direction. That's it for today.